This video is brought to you by Sporlan, quality, integrity, and tradition.
We've got an emergency service call. It is, let's see, Sunday, March 23rd. Customers complaining that water is leaking in the area of this kitchen AC. Now, from experience, this particular restaurant, all the drains go underneath the roof deck and they all connect. Typically, what can happen is if the main drain line plugs up, and again, just from years of experience here, it backs up at the kitchen AC, which is this one, and leaks in the area that they're complaining about. So all these other ACs are up above, and then they all tend to condensate, drain, and then it tends to come out of the kitchen AC right there. So let's just walk around. But the area that they're complaining the water's leaking from is where the restroom's at, which is right by this kitchen AC. So let me open up the return, have a look in here and see what we see. What the hell? 4 20 by 16 by 2s? They don't use the filter changing company anymore, but at every restaurant they had the wrong filters in these ACs. What kind of a filter is a 20 by 16? That's the stupidest thing. They had to take out the 4 16 by 16 by 2s that this AC probably takes, like whatever. Anyways, they're gone now. So, and this is how hilarious this is. We changed the filters already because we're doing the filter changes now. We put the right filters in here. So it's not 16 by 16, it's 16 by 20s. So we have the right size filters, but the previous company tried 16 by 16 by 2 and then also 20 by 16 by 2. It's just ridiculous. But all right, anyways, I'm going off on a tangent at this point. All right, when we look down in here, it's kind of hard to see. The drain pan for now is clear, it's dusty, okay? But there is moisture over in this corner. It's kind of hard probably for the camera to see, but right in there, that's a lot of moisture in the insulation in the bottom of the unit. So it was clearly overflowing at the drain pan for some reason. More than likely is gonna be a restriction, but we're gonna find out. I got the side of the unit taken off. We're gonna put some water in this drain pan and see what happens. I had to run a hose up here, we got that now. So we're gonna put some water and see if it drains. I suspect it's just gonna be a plugged up main. Always wanna make sure that there's actually water in the trap. There is, okay? And then what we're gonna do is just very carefully fill up the drain pan without overflowing into the duct. These ACs, you gotta be careful because the down shot is right there going down into the ducts and we don't want it to plug up. So I'm just gonna slowly put water in it and see if it starts draining. Or see if the thing just fills up. If you look right here, you could hear it draining. Right, it is draining, but very, very slow. Like, very slow. That pan is full of water and it's just sitting there. So it's not a very fast drain. I think it's gonna be just the plugged up main. You can see there it goes. It's like kind of going, kind of not going. All of a sudden it just sped up. Could be a restriction in this P-trap right here too. So we're gonna go ahead and get this guy pulled apart and we're gonna proceed with unplugging the main drain. The process is to disconnect every drain line, tape off the lowest ones, then go to the highest drain line, that one right there. Start from that one. Tape the hose to the drain going downstairs and just blast it with all the other ones taped off, because what you don't want is you don't want that restriction to cause it. If I have this drain line taped off and it was backing up into here, in theory, then it'll back up anywhere else, right? And you don't want it backing up into this AC and overflowing. So we're gonna pull every drain, and you can see that's why there's couplings right here. We're about to change these ACs too, then we'll put proper unions and everything, but you can see those couplings right there so that way we could take it off and blow it out. So that's what I'm gonna do right now. I'm gonna proceed with blowing out the main. So you can see that this one has a bunch of gunk inside the P-trap itself. It's kind of hard to get in there, but we're gonna get these taped off and then properly blown out, like I said. I know it seems silly and crude, but look at it. We just got an electrical tape to that guy blasting right now. Every other one is taped off. So that way it's not gonna back up into the AC. All the way up to here. And we're hoping that it's blowing it out down there. All right, it is not that dirty after all, so I don't think it's a plugged up main drain, but we had to start there. I'm gonna proceed with blowing out the other ones just to be safe real quick. and then we'll focus on this P-trap and see if maybe this P-trap's restricted and what's going on. Or it could simply be a problem with this AC, because we could have an AC that's icing up, leaking down into the duct. Who knows? There could be a lot of things. Let's see if we can get this in here to have a look at this P-trap. It's not going to be perfect. Nothing really stuck in the P-trap. The P-trap seems clear. Yeah, interesting. Okay, well, we're going to proceed with putting everything back together then, and making sure that this guy's clear. I'll double check that drain pan, then we'll turn on the unit and troubleshoot the unit from this point. I filled up the drain pan again, and it's draining a lot faster now. So I did find that there was a little bit of sediment buildup in the bottom of the drain pan, and it's clearing the drain pan within 30 seconds now. Like, it's all draining out. So maybe there was a slight restriction somewhere. This is interesting, huh? I opened up this section and look what I already found. So first stage compressor, and look, there's oil all over this guy. Let's see what happens. Is this guy leaking? Yeah, this guy's all full of oil. This CoreMax fitting is leaking. We don't know if that's the reason, but look at all the oil on the side of the compressor. And if the first stage is running low on refrigerant, in theory, that could cause a water leak too. So anyways, we're gonna get some probes on this guy and go through the circuit and see what we can find. See if it's low on gas. We're just working our way through this issue. This is our first heat wave. I wouldn't even call it a heat wave. We're supposed to hit 90 today. It is March 23rd. So it'll cool down. We have like rubber band weather where it'll be warm and then cool and then warm and then cool. And that's right now. So we're supposed to hit 90 today. It's supposed to be the warmest day. What I'm going to do quickly, I went ahead and rinsed real quick, wiped off the compressor. I didn't scrub it down, but just wiped off most of the oil. Just quickly run this by there. These leaks sometimes out of these CoreMax fittings. We know it's leaking there because there was oil everywhere. A little water in the thing. But if it has a rubber gasket, it's not going to hold back if the CoreMax is leaking, clearly, because there was oil everywhere, right? So we'll just quickly check everything else, check up here, check this unit, and then we're gonna fully probe up on this system and see if we can figure out what's going on. I'm trying to find the other suction. Oh, it's right here. Nothing there. Doesn't look like we're picking it up. I also don't have it on the highest setting. But we know it's there though, because clearly, yeah, there's like, it picks up a trace every once in a while. You see a little flash there. Every once in a while. So anyways, all right, we're gonna go ahead and probe up on this and see what's going on with the system. Check this out. This one had oil all over it, right? This one right here, I took the cap off. Can you hear that? It's just pissing gas out. That one is. If we put this guy right there, you'll be able to see it. Look at that. Bubble, bubble, bubble. And then this one right here has oil all in it. So these guys are leaking. Look at that. That's leaking good. So, okay. I'm going to go ahead and change out these CoreMax fittings real quick, even before I put gauges on the system, because I have my tool and I have the fittings, so we're gonna do it real quick. All right, it's gonna be a little tricky to get in here, so we gotta remove this. Got enough stuff up here. All right, now we can access that fitting. What we're gonna do is put a wrench right here and then a wrench right here, and we're gonna break this free carefully. There we go. Now that we got it free and loose, it'll be easier for the tool to get on there and grab it and twist it off. Do Do the same on this one. Okay, so this tool is called the CoreMax removal tool. Distributed and made, I believe, by JB. Or actually, I think Fast Test. I don't know if JB owns them or what, but they're the original people. And then I think JB just distributes it. It's not the greatest tool in the world, but we can get it going. It's better than nothing. That. Now, one thing that they didn't do is they need a bleed port because it always pops this gasket. There we go. We should have the fitting right there. There's the CoreMax fitting. Leaking CoreMax fitting. These things are notorious for leaking. So just load this other one in there. Push this in. I hope to get it twisted in. Okay. No fitting. We're good. Quick release comes off. And then we just torque it on and proceed with the next one. There we go. And then we'll just change the next one now. All right, we are gonna profile this system. So we're gonna hit profile. This unit is a 7.5 ton unit. So we're gonna set it up as a package unit. We're gonna set it up as multi-circuit. We got to go back into here. We got to go here and we got to switch to multi-circuit, heat pump, cooling, 2 to 4 compressors. There you go, 2 circuits. Then we're going to go to profile and we're going to set up the first compressor as a 4 and we'll set up the second compressor as a 3.5. It's not perfect, but it'll be close enough. Okay, 13 to 16 SEER. We do not have a TXV. We have a piston fixed metering device. Let's switch back to the other one. Change it to a piston fixed metering device. This unit has actuator metering devices. Yeah, that's it. So now we're probed in and we can go ahead and turn this unit on and then troubleshoot accordingly to see what's going on. Turn on the disconnect switch and we are going to jump out R to G. Okay. R to G. Indoor blower motor's running. And then we are going to jump out R to Y1. There's that. And then we are going to jump out R to Y2. Compressor number 1 is running. R to Y2. Now we got to put this panel right here. So that way we're not drawing in a bunch of air we don't want to. We'll put this one right here. And then we're going to watch this unit operate for a bit. Okay, we're basically going to let it dry because I did rinse off the condenser and the evaporator. Oh, interesting. Something just shut off. Looks like first stage just shut off on low pressure. So we're going to let it run for a minute, but this, okay, so I think, and the first stage is the one that the CoreMax fittings were leaking like crazy. So I think that first stage not running, what'll happen, this is very interesting, this evaporator over here is the top half is the second stage, the bottom half is the first stage, okay? And if the first stage is not running, the evaporator goes dry. There's not a lot of condensation on it. The second stage will run, and then the condensation will build up and run down the evaporator, and then sometimes it'll blow off or suck off the evaporator and leak down into the ductwork if the first stage is not working. And I think that was the case on this, because we know we had a rather large leak, and that first stage shut off on low pressure. It's not running right now. Actually, it looks like it pulled back in. But look, we're running at 6-degree evaporator temp on that first stage. So yeah, we need to go get some gas. We also need to make sure that the indoor blower motor's running. I'll do that real quick. But I heard it run, so it's moving air. Let's see what the second stage is doing. Second stage, what the heck? Second stage is running a really low saturation temp too. This is really odd. Are they both leaking? Oh yeah, we're frosting up like crazy. I need to check that evaporator to make sure we're moving the right amount of air, because both first and second stage are frosting up back here. Like they're frosting all the way up to the compressor. So yeah, we need to make sure that evaporator's moving the right amount of air. So let's jump in there real quick. I heard this thing turn on. I think it turned off somehow. It's not running at all. Let's go over here. Maybe it turned off. Let's go and look in here. Oh yeah, it popped off right here. Yeah, it fell off. I need to get that back on real quick. So that might not be our problem. We'll have to see. Let me put this back on. All right, now we're running. The alligator clamp came off because we're not using the thermostat right now. So I'm gonna put this on and we're gonna let it run for a bit and see what happens. I checked the belt tightness too, it's pretty decent. There we go. So it's gonna take a little bit to stabilize, but our saturation temperature is slowly coming up. Still really low on the second stage, 22 degrees. Let's go to the first stage. Still really low at 20 degrees saturation temp. So we're gonna let it run for a bit. Like I said, I had wet the condenser and the evaporator, so we're gonna let those dry out, let the unit operate, and make sure everything's working right. So we'll give it a few minutes. Airflow's looking low at 2,300 CFMs. We should be a little bit higher than that because we're a 7.5 ton. We should be at approximately 3,000 CFMs. One thing that I'm curious about though is temp split's not bad, but the outside air damper is partially open. So what I'm gonna do is disconnect it so the outside air damper closes, because we wanna see building temperatures. We don't wanna be bringing in outside air, so I'm curious what that does to our temp split. So we're gonna let it operate for a bit with the outside air damper closed and let it stabilize out. But I mean, right now, as far as everything goes, I mean, we have a 24-degree temp split. Superheat's kind of low on the first stage, meaning that it might slightly be overcharged. We'll have to see. Subcooling's not bad. Let's go ahead and go to the second stage. Second stage has high superheat, indicating we might be undercharged, possibly. We've got a smashed return downstairs, not giving us much airflow, so we're gonna hook up the actuator. Because it's Sunday, I'm not in here to replace ductwork right now. It's 11 a.m. on a Sunday. So what I'm gonna do is I'm gonna open up the outside air damper even more, bring in more outside air. Essentially, we're gonna be cooling the outside air just to give the unit airflow so that way it can function. We're gonna go into the settings and take a second here. It's alarms. Check out, advanced setup, system setup, set points. Set points, and then we're gonna go into here, minimum position. We're gonna go, it's at 4.5, so it's open like 10%. And it's a 2 to 10 volt system. So I'm gonna go way high. We're gonna bring in a lot of outside air for now, just to get them by until we can get them some airflow. It's not ideal doing this, but this will get us through the day because I can't get in there and do the ductwork right now. We gotta open up, we gotta move that return, we gotta do something because this AC is just starving for air. Now, I don't know if that has anything to do with what the problem was or not, because it wasn't leaking when I got here, but we went ahead and made sure we cleared out the drain. Unit's operational. Airflow is a little bit better, still not as high as I want it to be, but it's better. Delivered capacity slightly going up, 73,000 BTUs, kind of moving around. But superheat, I'm not gonna adjust refrigerant charge too much right now because it's pretty good, and I wanna get the airflow fixed before I start really going in there. It's not running below freezing for the saturation temp, so I think we're kinda okay for now. Circuit 1, we're right at where we should be actually. I think they're calling for like 9 degrees superheat. It's kind of fluctuating. Circuit 2 is definitely running a little bit high. Give it a second. Actually, sometimes it takes a second to kick in. Circuit 2 is actually running kind of low right now too at 3 degrees superheat. So, interesting. Yeah, now that we've given it airflow, they're actually both kind of low. Okay, well, that's all we're gonna do for now. We're not leaking water. We basically blew out the drain. It could have been plugged up. I never found anything boom that blew out of it, but I mean, we made sure we cleared the main. There was some stuff in the evaporator. That's all that they're gonna get from me for today. And we'll tell them to keep an eye on it, and we'll get that ductwork fixed and go from there. All right, we're getting up here to try to repair this. This is the crushed return, all nasty. We're gonna add some new returns to this building and move some stuff around. So it's not gonna be finished today, but we're getting started on it. So demo is later. We're just getting this cut. We're gonna get the new return added right here, and then we'll move things around. So we've got a new drop right here. We're currently putting duct sealer on it, getting it all sealed up, and then we're gonna push it up and then move on to the next. All right, we're up in here. It's not ideal, but we gotta cut into the bottom, which I'm not a huge fan of doing. I'd rather it be the sides, but they didn't give me much room, so we gotta do what we gotta do. Unfortunately, I only have a 10-inch hole cutter. So I use the start collar to mark it out. I'm gonna cut with the 10-inch and then do the rest with the 10 snips. It's kind of a bummer. I'm laying here. You guys can't see me. I'm upside down. It's tight in here. So I found it easier. I was trying to sit up here, but if I just lay down, I'm on a rail. It's easier to cut my round hole. So I'm getting there. I just almost done. Just got to get right here, clean this up, and then we'll get the start collar put on. You can see the bottom of my unit right there. All right, this is a mess. Start collar put on, duct sealer all under there, tightened on there. Just some webbing to kind of hold it because it's got to kind of go over this way a little bit. And then now we're going down and we'll do all the work from down there, but I got to get out of here. Interestingly, I don't know how I'm going to get out. It's going to be fun. All right, all that for that. And it's coming down right there. We're going to put the grill up there, pookie it, and then we got to get all these tiles and this light put back on and everything. I still got to cut this tile too because now they're going to have a grill there. So we added a return. We replaced the bad pinched one, and then we may or may not come back and replace the good one too. We'll see. We'll see what the customer wants. All right, so we're back up, straight up into there, right there. And then we came down here. We got this guy right here, nice and good. Not over tightening it, just duct sealed it down. All is well. And now we've got another return, so we're good to go. All right, now we're up on the roof. I went over to the economizer controller and we're closing down the outside air damper significantly, so that way we start pulling building air. We're gonna get it to a reasonable level, then we'll check static pressure, see where we're at on this unit. We just went through and cleaned all these units. This one does need new filters though. But I'll pull the filters out for testing purposes right now. But we're talking to the customer. They need to get the work orders for me to come in and change these filters because this was pulling so much outside air, the filters are just hammered. So waiting for the damper to close right now. It's just bringing in a little bit of outside air and then more building air than anything. Turns out that there's still a leak in the second stage. We had found that the CoreMax fittings were leaking. We changed those, but something else is going on because it's flat. But it's been a while since we started this. It's been like 2 months because we've been crazy busy. So we got some nitrogen, some 410. We're gonna pressurize this guy and see if we can find this leak. All right, for the life of us, we could not pick up a leak. We pressurized up to 300 PSI. Everything looked good. So what we're gonna do now is we're gonna go ahead and change the filter dryer because it was flat. And we're gonna do a pressure test with nitro again and then just pull a vacuum on it. All right, so we're gonna unsweat the dryer real quick. Pressure's relieved from the system. It's open to atmosphere. Okay. So now what we're gonna do is undo the top of this liquid line filter dryer right here. I unsweat this. Could be a flame out. Okay. Now, dryer's free. And then we can do this real quick right here. And then we'll sweat the other part in where it sits. Got that in. Now we're just going to pull this out real quick. Okay, Andy, come over here. I need you to hold this right here. Not crazy tight. Just hold it so I can pull this out. Okay, we've got that. Keep that over there because it's hot and we don't want it to fall. All right, and then now we're just gonna put everything back together and braze the other one in. It is tricky getting in here. Okay, so we've got the Viper wet rag heat blocking compound on the dryer. Got a Sporlan catch-all in there, got some nitrogen flowing through, and we just need to braze in this top piece right here, because when I took it out there was like a dimple on it and it won't let me slide it back in. So I'm going to slide this in here and then we'll do this last braze joint right here. Nothing about this is going to be perfect. There's my knuckles. Knuckle hair is overrated. Okay, now we got that, so I'm gonna apply some solder on this real quick. Let it melt down into it. Going down. Okay, that should be good. Now, let's see if I can get this into here. Possibly. This is a pain in the ass. Keep taking the torch across my knuckles and my arm. I have no more hair on my fingers. All that I'm going to do is give a little push on this, get that to pull into there, and then just heat it up. The solder's already there. Let it cool. Ain't nothing pretty about it. It's goobered up on the bottom, but it's going in the right direction. I'm gonna check it with the mirror. We'll get everything cleaned up. All right, we went with a Sporlan catch-all. I like to oversize them, so we went with a 16 cubic inch. This is good for up to 5 tons. These are like 3.5 ton, 4 ton compressors right in there, because this is a 7.5 ton unit. So Yeah, so we're just got it all cleaned up for the most part, strapped in. We're just waiting for the pressure test. All right, yeah, we're picking up a leak right over here, somewhere over here. And I kind of feel like we can hear it too, down here, right in here. And there's no welds on this side. This is just the return bin, so I bet you it's going to be in the fin pack. Maybe not. Huh. All right, we're going to pull the side off this unit. Well, no, I don't know if we are. Well, we found it. It's literally a crack. I thought there's no way. It's right there. All right, well, we're gonna sand it up even more and see if we can get a braze on that thing. Okay, so we've got nitrogen flowing through this, and I changed the tip to a 0 tip because this copper is gonna be really thin and it's probably gonna flare. We don't want it to explode on us. So what we're gonna do is just heat it up carefully. So we're just flowing the solder on there. Can we get a wet towel, please? I just burnt my hand. Oh, see, I just created a hole. So that happens, you got to learn how to patch those. So what we're gonna do is lay this on this side carefully, sticky, just like that, bend it over, heat it up. And then this copper's so thin, this happens. That's why I switched to the 0 tip and it still happened. And then we're just laying it across, and we're not filling it yet, and we'll flare it on the ends right here, and it'll magically fill it. And it's not going into the pipe all big, so it's gonna be a big old goober, but that's fine. Just put a little bit more where this crack was, because I don't know if the crack's gonna continue. If it leaks again, then we're gonna have to change the evaporator. Okay. I mean, that's gonna be it. It's pretty goobered up. Okay.
That was a great save.
All right, it's ugly as heck, but it'll hold again. And nobody ever said I was really good at brazing, so I'm just winging it over here. We had a little thing flare out. We just goobered on it. It's all good. We're gonna go ahead and get an evacuation going on this, and then we'll start assembling the unit. Hopefully that fixes it. So we should probably do a little pressure test real quick to make sure it's not pissing out everywhere. We just put some big blue on it. We'll put a little more. Definitely isn't pissing gas out anymore. So we're gonna give it a minute, make sure we don't see any micro bubbles or anything, but I don't think we are. I think we're gonna be okay. Wow, I'm surprised. That's a really strange spot for a leak. Really strange, because it was a crack. So if it cracked, it might happen again, because what caused it to crack? That's the scary thing. There's no screws there. There's no nothing rubbing up against that. That's just straight up a bad crack is all that it is. But all right, well, we're just gonna finish the pressure test real quick. Go ahead and hit enter, and it'll start the timer. I'm using the Fieldpiece S-Man 480V. I think 480V, this is the older one. And it's got the pressure test function. So put about 248 PSI in it, and we just hit start, and it times it and looks at the temperature. It's temperature compensated. We're gonna start assembling the side of this unit and then finish troubleshooting. It's not ideal pulling through a manifold gauge set, but we're holding on our vacuum. I mean, we're in decay right now, 823. So in reality, you wanna let the decay go just to make sure. But okay, we're gonna weigh in the 8.1 pounds into the second stage, and then we'll turn this guy on and put the probes on it and evaluate the whole system after that. All right, we are charged up. Put the 8.1 pounds in the second stage, hooked up my normal probes to it now. So this is still not completely stabilized out, but first stage is looking pretty darn good. Let's go ahead and switch over to second stage. Second stage is looking pretty darn good too. Superheat's really low, but we'll give it some time to stabilize out. Let's go look at our temperature splits. Amazing. Airflow looks amazing. Let's go ahead and get some static pressure on this thing while we're waiting for it to stabilize out. Look at that. 0.76 total external static. That is badass. So supply has 0.25. Return has negative 0.46. So yeah, we're looking freaking awesome. The airflow is much better now that we did that. We already closed the economizer. So now this unit can breathe. It actually has airflow. It's gonna be night and day difference inside that kitchen. The crazy thing is that this thing's been like this for years. Those ducts got all smashed down, and we're still not 100% done. We still got a few things we're gonna clean up down there. But added those extra. We moved the one that was pinched completely off. We added an extra one, so now they got 3 taps coming off that, 3 14s for a 7.5 ton. One of them has very little restriction because it's almost a straight shot down to that one we added in the waitress line. And now we're just gonna watch it come down in temp and start wrapping up all of our tools. But I'm glad to kind of finally be done with this one. We just, like I said, we still got a little more cleanup inside the kitchen, but we'll come back another morning and do that. I was looking at this unit, so if we come over here, on startup of this, on 2017, I measured 1.12 total external static. So, and then the ducts collapsed, the AC stopped working, it was starving for air, right? So I don't remember exactly what it was. I may or may not have it in this video, I don't know, but it was really high. And then now though, we've gotten it down to 0.73. So 0.35, supply 0.30 right in there. Actually, no, it's 0.39 for return. Yeah, dude, that is so, that is amazing for total external static. Holy crap. All right, well, this thing is working. So like I said, we're gonna clean up, and I think that's gonna wrap this one up. We still got a little bit of cleanup in the kitchen, but not anything worth an extra video for. We're just gonna move some ceiling tiles and stuff. But yeah, problem solved. I'm glad we fixed that leak. We were able to take care of that. This guy's running, and I'm glad to get this one off my list. We have so many projects that we can't finish right now that it just like this, we found this AC, and then all of a sudden they approved 3 new ACs over there. So then we changed those, and then life happened, we got busy, other stuff, and like I've been trying to get back to this one, and now we got it. So this is gonna be awesome. They're gonna be stoked in their kitchen. Next thing is they gotta let us start up these make-up air units. So we got these really old make-up air units that are just beat down. These things are disastrous. Probably gonna quote replacements. And then we can balance out the building even better. That'll be awesome too. We don't usually have jobs like that take 3 months to finish. But things have been kind of hectic. I've been short-staffed, and we're working on that. I have 2 new apprentices, and so, you know, we should have 4 to 5 people, and we're running it with 2 technicians, me and another one, and 2 apprentices right now. So it's a bit of a struggle, but we're getting it. We're getting it all figured out. And I got gnats flying around right now too, but we're getting it figured out. It's just taking time. But, you know, I'm always looking to hire an experienced technician, but I just haven't quite found the experienced technician that fit all the check marks, you know? So I decided just to start from scratch. And we have 2 great apprentices they are both doing amazing. They really are. If you guys are watching, you know, I'm proud of you guys. You guys are both doing really, really good. But it's just going to take time. It's going to take time to train them, to get them to where they do things the way that our company runs and the way that my brain works, you know? So anyways, we are a little behind right now, you know, and then we're going into summer, and we've got a lot of maintenances right now because we just got a big list of PMs to do for one of our customers. And then of course we have installs and all kinds of work, and so these are good problems to have, but they're also stressful too, you know. But we started this back in March, and that was the original service call. It was a water leak. Never really found the source of a water leak, right? I blew out the drain, did my best. So that's all we can do. When we can't find the problem, we just have to start from the basics, and let's make sure the drain's clear. You know, the drain pan was draining a little slow, so it could have been some sediment inside of there. It could have been that it was low on airflow. It could have been icing up. There were so many different things that it could have been, right? Don't know. So I got them going by temporarily opening up the outside air damper, right? So because we found a restriction, we found that the vitals were all acting kind of wonky. They were all over the place. Another thing to note right now too, because I'm sure I'm going to get a bajillion comments about it, is that I'm using an app called Measure Quick, and that app Measure Quick has an airflow estimation. It is not 100% accurate, okay? So I'm using that and I'm looking at it, but you also have to understand that, and as I was editing this, I was thinking about it too. When I'm opening up the outside air damper, probe placement changes, like all this different stuff happens and it throws everything off. So I know that we had really low airflow. I know we had restricted returns. It may not have completely been explicitly clear in the vitals that you guys saw, but we had airflow issues, right? Bottom line. You could see that on startup, or I wrote on the thing, it had 1.15 inches of total external static. And what did I say? We got it down to like 0.73, which is amazing. Okay. And people might ask, well, why didn't you fix it when you installed that unit? Because the customer didn't want to. It was working. And the other unit before that had 1.15 inches of total external static, you know? So sometimes they don't want to fix this stuff. Sometimes we don't have time to fix it. Life happens, you know? If we spent every single waking moment at a restaurant and fixed every problem, the restaurant corporation would go bankrupt, and you know, and we wouldn't have time to do anything else. So sometimes you got to just get things working, do your best. The customer didn't want to address the airflow problems, you know, the high total external static on that unit on install however many years ago. Bottom line, we're here now. I kicked myself in the butt because I didn't measure the total external static when I diagnosed it in this video though. I for the life of me, I thought I had it in my footage, but I don't know if I lost it or what, but like I do not have a clip showing me measuring total external static when I diagnosed a crushed return, but you clearly saw that the return was crushed. So there was only two 14-inch drops going to that unit, and both of them were restricted. So what we did was, well, I temporarily got the unit back up and running by opening the outside air damper back in March, cleared the drains, changed the CoreMax fittings because they had oil on them. I didn't have to add refrigerant. The reason why, people might ask, was because I previously had another technician back in March over there, and he found that the system was low on refrigerant, so he topped off the charge, and he told me that there was oil all over the compressor. I had been meaning to go out there, and then I got a service call for a water leak. So then I was like, okay, cool. While I'm out there, I already had a hunch it was going to be the CoreMax fittings. So that's why the charge wasn't horrible, because I had a technician top it off, right? So I changed the CoreMax fittings that Sunday just because I had the tool the day that my technician needed it. We only have one in our company right now. And so anyways, I changed the CoreMax fittings, got it going. That's why I didn't have to add gas that day. Found the crushed return, talked to my technician, told him, hey, if you look at the vitals, this was showing clear signs of no airflow, you know, learning lesson or whatever, right? So then, you know, we opened up the outside air damper, and then we just got busy, right? If you look in the clips of the video, when I was blowing out the drains, we had 3 old ACs that I was blowing the drains out on. And then if you look at the new clips, after I did the ductwork, you got 3 brand new ACs. Hence, you guys actually just saw the video. If you watch these videos in order, I believe my most recent video was me changing those AC units. So that was actually back in March. It's June now, or July now, actually. Dang, man, time flies. But when I did this work, I think it was June. Anyways, long story short. So we got them up and running, and then life happened. We got super busy. I couldn't get back out there. And then as the heat started kicking up, I was out there doing something else, and the customer's, hey man, are we going to fix that ductwork? And it was like, oh yeah, I got to get to that, you know? So we jumped back into it, and here we are. So we went out there, we used the existing ductwork. I just cut it shorter. We added new return grills, put them in a spot where the ductwork wasn't going underneath pipes and stuff, so it had a good, nice drop. So we got 2 returns right next to where it was in the kitchen. I ended up going back and replacing the other one. And then also we added another 14-inch return into the waitress line, which is still in the kitchen. So now they've got a lot of airflow going to that AC. We dropped the total external static. That unit's rated for 1 inch. We dropped it to 0.73. So that's better. Of course, I'd like to get it a little bit better, but you know, it's polishing a turd. You know, you're only going to get so much out of that. The plenum on that's pretty small too.
So we went ahead and fixed all the returns, and then when I went up to go check the total external static again after we did the ductwork, that's when I realized that the second stage was now completely flat. Okay, so in the video, if you pay attention to the clips, you know, at first I pressurized it and I really couldn't find anything. It was a really bizarre one. We couldn't hear it, and so believe it or not, that leak was still small. I pressurized to like 200 or 300 psi and it wasn't leaking out like crazy. But it was, I could see it moving, but it wasn't leaking out like crazy. But when I actually pulled that side panel off, so I went ahead and changed the dryer thinking that I didn't know if I was going to find the leak or not, but I definitely had to get some gas in it. So then I dove in and I pulled that side panel off and we found the leak, but I sanded it and it got bigger. So that's why you hear it pissing. It wasn't pissing like that, you know, when we first did that pressure test, but it was after I sanded it, I got in there and then I got my wire brush on my thing and just really started hitting that. And that's when it really popped up and it was like pissing out, right? The thing is that that is a crack. That is not a hole from a screw or a wire rubbing on it. That is a straight up crack. That's scary because that means that's a flaw in the pipe more than likely. And that crack is probably going to continue. They're probably going to have another leak on this. We'll have to keep an eye on it. You know, I mean, I brazed it all up, but if that pipe has internal bad copper or something like that that's causing that crack, I mean, and that's in the middle of the evaporator. It's not like it's at the top where the lines come in or the bottom where the lines go out or whatever. It's just right in the middle of the return bend. There's nothing that would have caused that other than bad copper. So I went ahead, sanded it up, brazed it up. Obviously, you saw I created a hole when I was brazing it. I tried using a zero tip, but oh well, whatever. I soldered the hole shut, all's good. And then we pulled the evacuation, and the unit obviously is doing a lot better now. The customer's been really happy. It's been a while, but the customer's been happy. I've been back a few times doing other things, and you know they've been good. That kitchen cooled down a lot. We still got more work to do because we got to put those makeup air units back in order. So I made a video, I don't know, a couple weeks ago, maybe a month ago, where I was at another location and we cleaned up the makeup air units, put new motors in them and started them up. We have several locations. There's probably 4 or 5 where the makeup air units are shut off. So we're going to have to start fixing these. We got a lot of new changes, Cal OSHA requirements here that regulate temperatures at which the kitchen staff works in, especially targeting restaurants. So all these restaurants are like really on it to get all these AC problems fixed. That's funny. Of course, the year that I'm short staffed, everybody's like, we need to get all this stuff fixed finally. And it's like, get in line. We'll do what we can do, you know? But like some of these makeup air units and stuff, these are like jobs for the winter time, really. You know, you start throwing on AC replacements, ice machine installs, PMs, you know, starting up units that haven't ran in years. Like, I mean, again, I'm thankful for the work, but I can only do so much. And that's why you saw in this video, there was like a 3-month gap between the start and the finish of this job. Because, you know, like I got busy and I had to prioritize more important stuff. So, you know, we got them running, but it wasn't too hot yet. But now that it's starting to get hot, I circled back and dialed this in, you know. So anyways, I'm flawed. I'm a human. I'm not perfect. I try my best. That's all I can do. I really appreciate you guys making it to the end of the video. Thank you so very much. If you're interested in supporting the channel, I'm going to tell you a little secret. The easiest way to support this channel is just watch the videos from beginning to end. That really is the easiest way. If you made it to this point, you made it to the end of the video, you watched it through, okay? That's the easiest way. But you can also support it by going to my website, HVACRvideos.com, where we have merchandise such as these hats right here available. Great way to help support the channel. We ship these out of our own home. My wife handles all the merch sales and merch orders and stuff, so you're keeping her moving and, you know, helping out the channel. So again, HVACRvideos.com if you want to support us there. You can also go to TrueTechTools.com. You see some of the cool tools that I was using in this video. The field piece, I think it's the SD-MN6 dual port manometer that I was using. That's from TrueTech Tools. You see the S-Man 480V, the older S-Man manifold. They have a newer model now too, but I haven't bought that. But maybe someday I will. Mine still works great. So, but I picked those all up from TrueTech Tools. If you go to TrueTechTools.com, you can use my affiliate code at checkout, and it'll get you a discount on majority of the items on their website. And then I get a commission from that order. So not only do you get a discount on majority of the items on their website, there's a few it doesn't apply to, but then when you do use my discount or affiliate code, I get a little commission from it. So it definitely another great way to help support the channel. You can also donate to the channel via PayPal, Patreon, YouTube channel memberships, which those are all just different ways that you can choose monthly plans, one-time donations, different stuff like that. So there's links in the show notes for all three of those. Yeah, and I think that's it. So I have to remind myself what I need to talk about, but I talked about my website, talked about TrueTech. Since I said them out of order, usually I say TrueTech at the end, it threw me off. So now my head's like, wait, did I say everything? I think I did. Hopefully I did. I'm sure you guys will remind me in the comments if I forgot something. I'm a little rushed and flustered in space case right now. And then also, I don't know if you guys can see it right here. This hand, look at the knuckles right here. You can see the knuckles are defined. And then look at these knuckles. You can't see that they're defined because it's all swollen. Because I don't know how to process emotions. And I got angry. And out of instinct, I decided that I wanted to satisfy my frustration by punching a table. Like literally a table sitting there. Last night I decided to just punch the table as hard as I could. And I felt an instant relief when I did it, and then instant regret because now my hand feels like it's broken. I don't think it's broken, but maybe it is. I've just been icing it. But yeah, today was a frustrating day trying to do a normal job, and my knuckles are all swollen from punching a table. So yeah, I got problems. Like I said, I'm a flawed individual. So I really appreciate you. I'm ranting and rambling. Thank you so very much for making it to the end. I will hopefully catch you on the next one.